Today we'll be introducing the notion of what's called residual plots. The reason for this is to see if a model works good or not. If it works well or not. Works good, works well. Works well, right. So, all right. So the first thing here, when we're doing a linear regression, what is the thing that tells me whether or not the data fits very well? So this is the correlation coefficient, and by the way, it only happens with linear regression. Remember, and we described this, and I even showed you the beginning of the formula. It was some mad, complicated formula. We'll never use it. We just let the calculator do it for us. What it does not tell me, if a linear is best. It just tells me how well that particular line works. But it doesn't say that line is the best way to describe it, okay? So that's what we're going to be chatting about today, is choosing our own best model. Next thing here, we're going to describe residual. Number one, residual is all about error, okay? And as it was described, it's based on the observed data. And what you do is you subtract the predicted data, which means that you will have some, if this is your predicted model, and you have some data that's above and below, etc., all you're doing is pretty much calculating the distance, no, I don't want to say distance, it's the difference above or below the curve. And it can be a line, it could be a curve, it could be a squiggle, squaggle, whatever. We chatted about how residual is important because it helps us describe how far away my data is from my model. So how much the observed is away from the predicted. So here's what we're going to do. We're going to show you how to plot what's called the residuals. So it's called a residual plot. So plotting, so what we're going to do is plotting the residuals. And what we're doing is, instead of having the original data point, the data points could be like this, like so, and some could be far, some could be close, or some could be very close. So just to have a scatter plot there. What we're doing is, we're going to be plotting the residuals above and below the x-axis. Now, it's not as simple as this, but it's similar to. Imagine I just have my model here in the scatter plot. And really what I do is just kind of rotate it so that this becomes my x-axis. And then we're just looking at the residuals there. Now, this is a bad situation because this right here is not the residual, but it looks like it. So let's explain a little bit further how that works. Notice at this data point right here, it's this far above. So over here, near the 1, it's going to be like this far above over here. I just want to point out that my scale is different. I'm counting here by 1s, and over here is counting by 20s. So that's why it's such a huge thing there. And just to look at this one, this residual right here is that. So it's going to plot more something like underneath right here. And keep going. This one is also under near the 2, and it looks like it's slightly farther than that other one. And this is just stuff I'm making up, so your data might look slightly different. The residual for this one, about at 2.5, is just slightly above, so probably something like this. You don't need those lines. I'm just bringing them over. So the residual here for about 3.5 is under, so it's going to be somewhere around there. This one is way far. In fact, that one's going to be probably off my chart, something like that. This one is really tight, so it's going to be somewhere about here. All right, so what this does is it helps us to see where the data actually is. Is my data evenly balanced, some of it above and some of it below my model? Or is it scattered all over the place in some other funny shapes? So there are 3 ways of interpreting right here, and it looks like this. If your residual plot does this, above and below the x-axis, and it's clustered very nearby it, then that means we have a very good model. The model itself. whether you're doing a quadratic model, exponential model, power model, whatever, your residuals show you that it's a pretty good situation. If anything else happens, in this case, almost everything is above, and the distances are changing. But notice there's a pattern there. So this is a weak model. And lastly, this is a weak model too, primarily because of the funnel shape. So what we're looking for is a nice little cloud that's above and below, evenly distributed across.
Now we're going to take a look at page 2. And our activity 1 here says the table at the right here shows the length of day L from sunrise to sunset. And we're going to, compute it at a city in the northern hemisphere. So every 10 days for 100 days. So starting at August 31st, 10 days later, etc. So this is roughly 3 months later. And this is the data collected. And as we see, the days are getting shorter. So let's make a regression line and let's see what we do after we enter the data L1 and L2, L1, L2, and then do stat calc. Here's our regression line, and let me go ahead and write that down with rounding it out a little bit. The regression line is approximately negative, so y equals negative 2.45x plus 786. Plus 786. All right. So we already stored that into y1, and we see that our regression coefficient is really good there. It's 0.9924. So right now, because of that high number, that number's very close to 1, we say it's a very strong correlation. Okay, however, when we do graph, we see this, and one thing we notice is I see a lot of the data is underneath my regression line. This one looks like it's on, that one's above, that might be on or above, etc. So we want to see what this doesn't show us. It shows us a strong correlation, but what does it not show us? So what you're going to do is go to Stat Edit and go to L3, and when you plug in Y1, parentheses L1, it's going to take the function and evaluate it at all these numbers, and when you do that, you get these. So here we have our observed values, and here's my predicted values based on my model. Now, I think some of your calculators won't work when we do this, so I'm going to avoid maybe this residual and instead just have you say, well, let's take the observed and we're going to subtract the predicted. So instead of calculating residual, do that. So here is L4, and you're going to type in right there L2 minus L3. And when you do that, you get these numbers. And as you see, these numbers are hovering near 0. This one's above, 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 below, 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 below. And as we saw earlier, we do see a bunch of things below. I don't have the exhaustive list here. So let's continue on and see what we have. Now when we plot L1 versus L4, how do we do that? I go into Stat Plot, which is above the y equals button. You're going to turn it on, make sure it's turned on, and I'm going to select L4 instead of L2. Then when we go to zoom and zoom fit the data here, notice that we have a bunch of data that's above the axis, a bunch of data that's below. However, remember what we wanted. We wanted to see, if this is my x-axis, I wanted to see a nice little cloud of data that's all hovering in the same region and very close to the x. So here, because there is a distinct pattern of error, because that's what residual is, error, a distinct pattern to the error, this shows that although the model is a good fit, it is not the best model. So it turns out when you collect more data for the whole year, this is actually what the data is going to look like. It's going to go up and down and up and down like this for all the years. Just to give you some perspective on what this is, this being the longest day of the year is going to be in June. That's the summer equinox, the summer solstice. And the lowest day of the year is right here, the shortest day of the year in December 21st-ish. And that's the winter solstice. And then we've got two other data. So this one here would be the fall equinox, the spring equinox, etc. And so they're called equinox because they are the same length of day. So it turns out that this is more like a sine or a cosine function. So it's a wave like this and just goes throughout the years, repeating that process there. All right. So that was the experiment that we wanted to do, was to show, number one, to calculate our regression line and to see that it is a strong fit. However, it turns out that it's not the best model. So we're going to try to predict which model is the best. So as you walk through activity 2 here, first, the hint I'll give you is since this is about population, you're going to want to choose the model that best fits population. So that's going to go here, and then you're going to use that information to plot residuals. Turns out that when you do that, it's not going to fit so well, so we're going to try a different one, quad reg, down here, and plot the residuals and see how those compare here. All right, you're good to go.